deviation. Lesson 1. Ungrouped data. Secondary 4G3 Mathematics. Let's start with a quick recap of what you already know. If the lower quartile of exam scores is 40 and the upper quartile is 70, the interquartile range is 30. This measures the range of the middle 50% of values. Now imagine you are a basketball coach choosing between two players. Both average 20 points per game. Player A scores between 18 and 22 points every game. Very consistent. Player B sometimes scores 35 and sometimes just 5. Very unpredictable. Their means are the same, but their consistency is completely different. Mean and median measure central tendency. IQR compares the middle 50%. But is there a tool that considers all the data to measure spread? Yes, it is called standard deviation. Standard deviation measures how spread out data values are from the mean. A small standard deviation means data is clustered close to the mean, consistent. A large standard deviation means data is spread far from the mean, inconsistent. Let me show you visually. Here are two data sets, both with a mean of 20. The top set has values clustered tightly around 20, small standard deviation. The bottom set has values spread far from 20, large standard deviation. Key idea: standard deviation captures the average distance of data values from their mean. But we use squared differences, not plain differences, to avoid negatives canceling out. Here is method 1. Sigma equals the square root of the sum of x minus x bar, all squared, divided by n. Let me break down each part. X bar is the mean of the data. X minus x bar is the difference of each value from the mean. We square each difference to remove negatives. Sigma means sum. Add up all the squared differences. Divide by n, the total frequency. And finally, take the square root. Let's work through an example. The scores for 5 subjects are 50, 55, 60, 70, and 90. Step 1. Find the mean. Add them up. 325 divided by 5 equals 65. Step 2. Build a table. For each score, find x minus x bar, then square it. 50 minus 65 is negative 15, squared is 225. 55 minus 65 is negative 10, squared is 100. 60 minus 65 is negative 5, squared is 25. 70 minus 65 is 5, squared is 25. 90 minus 65 is 25, squared is 625. Step 3. Sum them up. 225 plus 100 plus 25 plus 25 plus 625 equals 1,000. Step 4. Divide by north and take the square root. Sigma equals the square root of 1,000 over 5, which is the square root of 200, equals 14.1 to 3 significant figures. Thought-provoking question. What would the standard deviation be if all 5 scores were the same, say 65? The answer is sigma equals 0 because there is no spread at all. Now let's learn method 2, the alternative formula. Sigma equals the square root of the sum of x squared over n minus the mean squared. In words, the square root of the mean of squares minus the square of the mean. This formula is provided on your exam formula page. Method 2 is often quicker for calculation. Let me break it down. Sigma x squared means square each data value, then add them all up. Sigma x over n is simply the mean. Let's verify with the same data: 50, 55, 60, 70, 90. Step 1. Find sigma x squared. 50 squared plus 55 squared plus 60 squared plus 70 squared plus 90 squared equals 22125. Step 2. The mean is 65. Step 3. Apply the formula. Sigma equals the square root of 22,125 over 5 minus 65 squared. That's the square root of 4,425 minus 4,225 equals the square root of 200, which gives us 14.1 to 3 significant figures. Same answer. Both methods give the same answer. You can use whichever you prefer. You can also use your scientific calculator to find standard deviation directly. On a Casio FX991, first press Mode, then 3 for statistics, then 1 for one variable data. Enter each data value, pressing equals after each. Press AC, then Shift 1, then 4 for variables. Select sigma x and press equals. The display reads 14.14, which confirms our answer. For data with repeated values, enable the frequency column first. Press Shift mode to access setup. Scroll down, press 4 for stat, then 1 to turn on the frequency column. Now enter stat mode and input X values with their frequencies. Remember, always use the calculator to check your manual working, but show full working in exams. Here's a medium difficulty example. The heights in centimeters of 8 students are shown. Using method 2, n equals 8, the sum of x is 1312, and the mean is 164. The sum of x squared is 215,444. Sigma equals the square root of 215,444 over 8 minus 164 squared. That's the square root of 26,930.5 minus 26,896, which equals the square root of 34.5. Sigma equals 5.87 to 3 significant figures. Now, a frequency table example. The number of goals scored by a team in 20 matches. We add columns for fx and fx squared. The sum of fx 20, the sum of fx is 35, and the sum of fx squared is 85. Now apply the formula. The mean is 35 over 20 equals 1.75. Sigma equals the square root of 85 over 20 minus 1.75 squared. That's the square root of 4.25 minus 3.0625 equals the square root of 1.1875. Sigma equals 1.09 to 3 significant figures. Quiz time! Question 1. A data set consists of 4, 6, 8, 10, 12. Find the standard deviation. Have you got your answer? The answer is B, 2.83. The mean is 40 over 5, which is 8. The sum of squared differences is 16 plus 4 plus 0 plus 4 plus 16 equals 40. Sigma equals the square root of 40 over 5, which is the square root of 8, equals 2.83 to 3 significant figures. Question 2. The sum of 6 data values is 78, and the sum of squares is 1086. Find the standard deviation. Think carefully. Which formula should you use? The answer is B, 3.46. The mean is 78 over 6, which is 13. Sigma equals the square root of 1086 over 6 minus 13 squared. That's the square root of 181 minus 169, which is the square root of 12. 3.46 to 3 significant figures. Let's revisit our basketball players. Player A scores 18, 19, 20, 21, 22. Sigma A equals the square root of 2, which is 1.41. Player B scores 5, 12, 20, 28, 35. Sigma B equals the square root of 106, which is 10.3. Player A has a much smaller standard deviation, meaning much more consistent scoring. As a coach, you would probably pick player A for reliability. Standard deviation gives us a precise way to measure consistency. Let's summarize what we've learned. Standard deviation measures spread from the mean. Method 1 uses the sum of squared differences from the mean. Method 2 uses the mean of squares minus the square of the mean. This one is on your exam formula page. Small SD means consistent data. Large SD means spread out data. And always use your calculator to check you're working. Next lesson, we will apply standard deviation to group data and learn how to compare two datasets.